As we finalize this chapter on functions, there's a couple more important things we need to talk about. One of them is the idea of horizontal intercepts. We've talked at length about vertical intercepts, but we haven't really talked about horizontal intercepts, and then this idea of finding a point of intersection. And so I've highlighted a couple of key things on the student page. It's talking about the percent of women age 65 or older living alone, and that the data is increasing and then decreasing. And one significant piece there is that at 0%, it's suggested that this will occur, that 0% of the women will be living alone in the year 2036. And if we wanted to use that value in our set of data, because we're going to graph the data including the point that's suggested here, and so 2036 years after 1930, that's going to be 106 years, and we know that value is 0%. And so I've sketched the graph for us, and remembering to indicate the input and output, the proper variables that go with it, and then I'm sketching a rather smooth curve here. It's trying to get all the points, and I missed a couple there, but it's and we can talk about it whether it's discrete or continuous, but looking at years, we can break up years into months and days, and so it suggests that the data can be continuous. And so I want to jump to part C, where it says, where does the graph cross or touch the horizontal axis? And it was at this point here, the one that we were referring to, and so we know that this point is 106, 0. And what does this value represent in terms of the problem, in the context of the problem? So we could say 106 years after or since 1930, or you could say in the year, what was that, 2036, and then we can finish that statement with 0% of the women age 65 or older would be living alone. So the definition of horizontal intercept we talked about on day 1 of this functions unit, and we said it was a point where the graph crosses, we could also say crosses or touches, the horizontal axis. And we know that that point is always got the ordered pair of some value, some input value, and the output value is always 0. So anytime we're crossing or any point along this horizontal axis, the input value is some value, but the output never moves up and down, it's always at 0. So we know that the horizontal intercept is always something 0. So now if we want to state the practical domain and practical range, we can look at our graph, and our practical domain is from 0 to 106, and our practical range is going to go from 0 to that highest point, which looks to be about, what is it in terms of the data, was 38.3, and so we could fill those in with 0 less than or equal to the variable of y, which is less than or equal to 106, and then we had 0 less than or equal to, I think our variable was p, and that value is 38.3. Okay, so this is just general review from the exam, from the last couple of ideas that we've been doing, except now we're focusing on this idea of horizontal intercept. So we want to solve for the horizontal intercept, this particular function. And so again, if the horizontal intercept is some value and 0, we know that n is our input and t is our output, so t has to be the 0. So we're going to set up the equation 0 equals 4 minus 7n, and this is constructed by n being multiplied by -7, and it's being that product is being added by 4, so that means we're going to subtract 4, and then we're going to divide by -7, so we have 4 7s equals n, and we want to write this as an ordered pair because it is a point. And so we have the point 4, 7, 0 as that horizontal intercept.